Hello everyone. In this section on numeration systems, we are going to talk about computation in other bases. That means how to perform the basic mathematical operations on numbers represented in bases which are not decimal bases that we are familiar with. So it'll be working with base 2, base 3, base 5. It can be any base all the way up to hexadecimals, which is base 16. All right, and what do we mean by the basic operations? They are the addition, subtraction, multiplication, and division. So we are going to learn how to perform all those operations with numbers represented in different bases. Therefore, in this section, we are going to talk about how to add, subtract, multiply, and divide numerals with bases other than base 10. Now, we are going to start with the operation of addition with different bases. However, I would like to review the process of adding decimal numbers because for different bases, we are pretty much going to use the same principles, the same rules, but it's going to vary depending on the base that we are working with. All right, so this is a process you probably were taught in grade school when we first learned how to add, subtract, and all that, but let's go over it because nowadays we use calculators for additions and we are not using consciously some of the rules that we had learned years before. All right, so let's go through the process here. Suppose we have this number here, 639 plus 320. All right, if we were to perform this addition in base 10, what would we do? We would first start with the rightmost digit where we will start by adding 9 and 0. So 9 plus 0 is 9, right? So you're going to write the 9 in the rightmost place, rightmost in the units place rather. And then you are going to go to the next digit. The next digit here is 3 and 2, right? 3 and 2, so you're going to add those up. So you're going to write 5, and 6 plus 3 is 9. So the answer is 959. Now, this was, in this particular problem, there was no carryover. All right, you remember the concept of carrying over to the left digit. And when do we carry over? We carry over when the sum of the two digits add up to anything greater than 9. So let's review that. We have these numerals. What are the numerals we use for base 10? We start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so these are the numerals. Remember, the last numeral, or the highest numeral, has to be one less than whatever the base is. So if the base is 10, the highest we can go is up to 9. So as long as when we sum two values, two digits, and they don't go over 9, there's no carryover involved, right? What happens if if we were to perform this addition? 639 plus 392. All right, let's do this addition. As you can see, we will end up performing some carryovers here. We always start with the rightmost digit in addition, correct? So what do we do here? 9 plus 2 is 11, right? So 11 is more than 9, correct? 9 plus 2 is 11. 11 is more than 9. We cannot just write here 11 like this, correct? We since 11 is greater than 9, what we do is we put the 1, and let me get the eraser out, or what I wrote here. We will, 9 plus 2 is 11, so we are going to write the 1 from the 11, correct? So 9 plus 2 is 11, so we are going to write the units digit over here, and we are essentially carrying over 10. 11 is equivalent to 10 plus 1, all right? So here we are working with bundles of 10 because we are working with base 10 decimals. So 11, think of 11 as 10 plus 1, right? And we write the 1 over here, and we carry over the 10 to the left, the left unit, the left digit, like the tens place, right? So to the next left, to the rightmost place. So over here it's 10, but 10 is one bundle of 10. So think of it in terms of a bundle of 10. In decimals, we are dealing with bundles of 10. So to carry over the 11, we write the units value on the rightmost digit over here, and we carry over a bundle of 10, and then we do the addition. 9 plus 1, 10, plus 3, 13. So we again 13. All right, so 9 plus 3 plus 1 is 13. 13 is how much? 10 plus 3, correct? So there's a bundle of 10, and this remaining 3 we write under 9, 3 plus 9, all right? And we carry over a bundle of 10, which is a 1. All right, and now let's perform this addition. It's 6 plus 1, 7, plus 3 is 10. So this is the answer. All right, so this is the process of addition whenever we go over 9, which is the last numeral in our decimal system. We have to perform the carryover method. We have to carry over bundle of 10 to the next place on the left. And then if the sum of the values, all right, sum of the values in the next place is also over 9, then we have to carry over a bundle of 10 to the next leftmost place, and perform and write the rightmost digit over here below 3 plus 9. That's what we did. All right, so this is how we are going to work through addition in other bases as well. So I just wanted to review the rules of decimal addition, because that rule is going to get applied to any base that we work with. Now we are going to learn about binary addition, or addition in base 2. All right, so we are going to add binary values, which is also base 2 values. Now let's note the numerals that would be used, or that are there in a base 2 system. The only numerals in the base 2 system are 0 and 1. And recall that the highest numeral should be 1 less than whatever your base is. So if your base is 2, then the numerals can go as high as 1 less than whatever base you're using. If you're working with base 3, then your numerals will go up to 2. So it'll be 0, 1, 2. If you're using base 5, it'll go as high as 4, but there won't be a numeral for 5. So that's how it works in the numeration system. So for base 2, we have 2 numerals, but the highest numeral is a 1. All right, now let's learn how we can add the different combinations of 0 and 1 in base 2, and how or when we will be applying the carryover rule in this addition. All right, so 0 plus 1, 0 plus 1 would be 1, correct? We will be performing a carryover only if we go over the 1. Here 0 plus 1 is a 1, so we just write the 1. The next one would be, well, we should have started with 0 and 0. So let's do it here. 0 plus 0 would be a 0, and that we have numerals for those, 0 and 1. It's within our new set of numerals. So 0 plus 0 is a 0. Then we did 0 plus 1 is a 1. And then 1 plus 0, 1 plus 0 is a 1. So we have a numeral for 1, so we write the 1. There's no carryover involved as of yet. However, when we go to add 1 and 1, what happens is the 1 plus 1 is a 2, correct? 1 plus 1 is a 2, and we don't have a numeral, for 2, right? So when we say 1 plus 1 is 2, we have to think in terms of bundles. All right, so what this means is 1 plus 1 is a bundle of 2, one bundle of 2 plus 0, right? So there's a bundle of 2, and I'll write here bundle. So one bundle of 2 plus a 0. So what we are going to write here, instead of a 2, since there's no numeral in the system, in the binary system for 2, so we are going to write 0, this 0 over here, and carry over the one bundle to the left side. All right, and then 1 plus 0 is a 1. So the number 2 in binary is written as 1, 0. All right, now let's pull up some of the information here, because they have built a table with all the additions possible between 0 and 1. All right, so let's look at that. It says here an addition table, and let me erase some of these markings here so we can read what came up. It says an addition table can be made for any base and be used to add in that base. And these are the values here which you've been seeing displayed from the start. 0 plus 0 is a 0. 0 plus 1 is a 1. 1 plus 0 is a 1. Same thing what we had worked here, but 1 plus 1 is 1, 0, and that's what we came up when we added 1 plus 1. All right, now it's not possible to have a table for every base. For a base 2 system, it's a small table, but when we work with base 12 or even base 8, 12, 16, it's going to be a huge matrix. So we are going to use the principles of carrying over bundles for that base, all right, to the next left place as we go on in the addition whenever there is a carryover. All right, so let's perform an addition in a different base now. Let's see if there's any other information on this slide here before we go on to the next one. This just says this is the base 2 addition table. Here's the table, and we just went over that. Here's an example of base 5 addition that we need to perform. They have given us these two values to add: 34 base 5 plus 23 base 5. They've also provided us with a table, but I'm not going to use the table to perform the addition because you will not be provided tables on tests and assignments, and it's not possible to memorize them either, so we will refrain from using tables. Instead, we are going to use the process we just discussed about carrying over in bundles. All right, in bundles of whatever base we are using. So I'm going to go through this example step by step. So whenever there's a carryover, we will be carrying over in bundles of the base value. So let's first start by listing the numerals in the base 5 system. In base 5 system, we start with 0, and then there's 1, 2, 3, and the highest we go is a 4. Remember that in any numeration system, the highest numeral will be one less than whatever base we are working with. So if it's base 5, we can go as high as 4. If it's base 7, we can go as high as 6. If it's a base 16, we go as high as 15, one less than whatever base we are using. All right, so 0, 1, 2, 3, 4. Now, as long as the value, the sum of our addition is within these numerals, we don't need to carry over. If it goes above the highest value, then we will have to start carrying over in bundles. So let's go through this step by step. All right. So let's look at the rightmost column. 4 plus 3 is what we are adding in base 5. So let's do the addition here. We have 4 plus 3, and remind yourself this is all in base 5 by putting the subscript, is equal to 7 base 5, correct? Now 7 is higher than the highest numeral we have, is greater than 4, correct? We do not have a numeral to represent a 7. So what we do is we will be extracting a bundle of 5 from the 7 and carrying over that bundle to the next leftmost column. All right, left column rather. So let's extract a bundle of 5 from the 7, and we will end up with a 5. Once we extract the 5, what are we left with? We are left with a 2, right? That's what we are left with. So we are going to write this leftover value, which is a 2, under the rightmost column, the one under 4 and 3. It's going to be a 2, and I'm going to subscript this with a 5. And this bundle, all right, this one bundle of 5 is going to be carried over to the next column here. All right, it's going to be carried over here. Okay, so now we will do the addition of this left-hand column here. All right, this column here. So let's write that out. We have 1 plus 3 plus 2 is 1 plus 3 plus 2 is a 6. Now 6 again is a value which we cannot represent by the numeral in the base 5 system. So it is greater than 4. We have to now extract a bundle of 5 from the 6 and write it as what? When we extract a 5 from the 6, we are left over with a 1, correct? So there's one bundle of 5 and we are left over with a 1, and that 1 gets carried over and put in here. All right, this is 1. This is where 1 is placed. And what happens to this bundle of 5 that we extracted? It's placed, carried over to the next position. We write the 1 here. All right, this is the 1. And then we do the addition of this third column from the left. So 1 plus 0 is a 1. So our answer from adding 34 base 5 and 23 base 5 is 112 base 5. So we perform this entire addition without referring to this table, and that's how you have to work on the test as well. Okay. Now we will learn the process of subtraction in different bases, but before that, I'm going to go over the process of subtraction with decimals because we are going to use the similar process for subtraction in the other bases. All right, so let's start with a simple number here, 374 minus 242. All right, and we have to subtract this number. We always start with the rightmost column again, just like in addition. We start with the rightmost column. 4 minus 2 is a 2. 4 minus 2 is a 2. 7 minus 4 is also 7 minus 4 is a 3. So 3. And 3 minus 2 is a 1 for an answer of 132. This is all base 10. However, if we have to perform this subtraction here with decimals, let's just make it 374 minus 286. All right, how do we go about this subtraction? We again start with the rightmost column, but here we see that the number on top is a 4 and the number at the bottom is a 6. So the bottom number is greater than the number above it, right? 4 minus 6 would give a negative number, negative answer, correct? So what we do is we have to borrow a tens from the left column here. All right, so what I'm going to do is I'm going to borrow a 10, a bundle of 10 rather, all right, and make this a 14. So I've borrowed a bundle of 10 from the from the 7, all right, and when I do that, the 7 becomes 6, all right, it becomes 6. So now we do the subtraction of the rightmost column, since now we have 14 minus 6, right? So 14 minus 6 would be 8. 14 minus 6 is 8. Now we look at the next column to the left. So we have 6 minus 8, right? No longer it's 7 because we took a bundle of tens from the 7. So now there's 6, all right? It's got reduced by one bundle. So 7 becomes a 6. So 6 is less than 8, isn't it? 6 is less than 8. So again, we have to do some borrowing from the column to its left. So we have to borrow one bundle of tens from the 3s. So this is going to be, all right, I'm going to make this a 2 and give a bundle of tens to make this 16, So 16 minus 8 is 8, correct? And then 2 minus 2 is 0, all right? We don't need to borrow because 2 and 2 are equal. It's 0. So our answer is going to be 88, all right? So this is how we subtract, the process of subtraction. With decimals, we are going to apply the same process for different bases, except when we are working with base 5, instead of giving a bundle of or borrowing a bundle of tens, we are going to borrow bundles of 5 if that's what we are working with, if that's the base we are working with, or a bundle of 2s if we are working with binary bases, base 2, or a bundle of 16 if we are working with hexadecimal, and so on. So here's the process of subtraction step by step. So it says subtraction can also be performed in other bases. When you borrow the amount of the base given in the subtraction. So when we worked with decimals, we were borrowing tens and adding it to the number on top. So when we did the subtraction with 4 and 6 in the first column in our example before, we had to borrow a bundle of 10 from the left column, all right, and then added it to 4 to make it 14, and then we did 14 minus 6, correct? So here too, when we borrow in other decimals, instead of borrowing tens, we will borrow the amount of the base. All right. So if we are working in base 5, then we are going to borrow a bundle of fives from the left column and add it to the number on top of the right column and then perform the subtraction. So that's what it says here. When you borrow the amount of the base given in the subtraction problem. Then, so if it says here, if you are subtracting in base 5, when you borrow 5, right? That's what I just said. And then finally, if you are subtracting in base 12, when you borrow 12. That's all. All right. So let's go through an example and see how that process would work for a different base other than the decimal. Let's perform this subtraction in base 12, all right? So 97a base 12 minus 4b8 base 12, all right? How do we go about this? First, I'm going to list the numerals of base 12. We start from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have a and b. All right, A is for the 10 and B is for 11, correct? Now let's go here and see how to perform it. So A is a 10, keep that in mind. We start with the right column. A is a 10 and 8 is less than 10, so 10 minus 8 is a 2. So I'm going to write the 2 here, right? The column left to it has a 7 and then B is 11. So 7 is less than 11. So we have to do some borrowing here. All right, we have to do some borrowing. So we have to borrow now a bundle from the column to its left, but this time the bundle is going to be that of 12. It's going to be a bundle of 12 is what we are going to borrow. All right, so when I borrow a bundle from this column here, the 9 is going to become an 8, but over here we have given a 12, all right, a bundle of 12 to the 7. So what we have to do is we have to add this 12 to the 7. So 12 plus 7, right? 12 plus 7 equals 19. So 19 minus b is what we are going to do. 19 minus b. So what is b? B is 11, right? So b is 11. So 19 minus 11 is going to be an 8, correct? So I'm going to write 8 under the column for 7 and b, and then go to the column to its left to do the subtraction. So 8 is greater than 4. We are good here. So 8 minus 4 is a 4. Right? So our answer is 482. And please put a subscript for the base to indicate that this is base 12. Otherwise, people would think that this is a decimal. All right. So whenever we are working with any other base other than 10, we have to put a subscript of the base. It's only for the decimal that we do not need to use a subscript, because it's understood when the subscript is not visible, that means it is base 10. All right. Now let's go over the multiplication process in other bases. Again, I'm going to start by multiplying two decimal values, two simple decimal values. So let's take these numbers here. 4 multiplied by 3. All right, so 4 multiplied by 3 in decimals, when they are in base 10, we just multiply 4 and 3. 4 3s are 12. So we write 12 for our answer, correct? When we are multiplying the same values in base 5, what happens is, let's say we have 4 base 5 multiplied by 3 base 5. What we need to do is we will be extracting bundles of 5, all right? Either one bundle of 5 or multiple bundles of 5 from the product we get after multiplying 4 and 3. And let me run through this example here. We know that 4 times 3 is 12 in decimals, right? So 4 times 3 is 12. 4 multiplied by 3 in decimals is a 12. So let's do it the decimal way to start with. And then what we do to convert this to base 5, we will see how many multiples of 5s, right? We are working with base 5. So how many multiples of 5 can be extracted from this 12, right? So we can see there are two multiples of 5, right? So let's see here. 12 can be written as 10 plus 2, correct? 12 can be written as 10 plus 2 or rewritten as 10 plus 2. And in 10, there are two bundles of 5. So we have 2 times 5. So 10 can be written as or rewritten as 2 times 5. So there are two bundles of 5 in the tens plus 2. That's the leftover after we extract two bundles of 5 from the 12, right? So we are going to write this 2 first on the right side, as the rightmost digit 2. And how many bundles of 5 did we extract? 2 bundles, right? So this value here, this 2 is going to be put to the left of the other 2 for a value of 22. Put the subscript of 5 on the right side. So 22 base 5 is the result of multiplying 4 base 5 times 3 base 5. All right. So that's how we are going to work through the multiplication problems, where we first multiply them as decimals, and then we are going to extract bundles of 5, and the leftover values are going to be on the right hand side, and then the number of bundles we extracted for that particular base, be it 5 or 7 or 9 or 12, anything, that multiple we are going to put on the left, all right, to the left. So 4 base 5 times 3 base 5 is a 22 base 5. So let's look at the solution that they have provided to us. It says that it may be easier to multiply the values in the base 10 system. So that's what we did here. We first multiplied as if we were multiplying decimal values, and then change the product to base 5. And that's exactly what we did here. All right, we first multiplied them as decimals, got the value of 12, and then we changed the product to base 5. How did we do that? We extracted multiples of 5, all right, from that value, and then we put the leftover value, we wrote that first to the right, and the multiples of 5 that we extracted was put to its left. So let's just look at what they're saying here. Multiplying 4 times 3 in base 10 gives 12, right? That's what we got. And then Converting 12 from base 10 to base 5 gives 22 base 5, right? And that's what the answer we got as well, all right? Let's look at a slightly more challenging problem here in multiplication, and this time multiplication in base 7, right? Again, we are going to start as if multiplying in decimal, and then we are going to extract multiples of 7 from the product and work like that, all right? So over here, we have, let's do the work at the side before we reveal the final answer. 43 times 25. Again, keep in mind these are all base 7s. All right, these are all base 7s, though I haven't written it, but I'll write it in the final answer. All right, so first we multiply 43 by 5. First, I'm going to multiply 43 by 5 with, and then I'm going to multiply 43 by 2, just the way we multiply in decimals, and then add them. But we are going to go through the process of extracting 7s or multiples of 7s from the product and adjusting our values. And at the end, we are going to add the two rows that we get after multiplying by 5 and then by 2, and then we will perform the addition to get the final answer. All right. And let me just indicate in any case that these are all in 7s, multiples of 7s. So we start by multiplying 43 and 5. So I'm going to do that on the side. So 43 times 5. 5 3s are 15, correct? So 5 3s are 15. So, and let me just give me a few seconds here. 15, 5, 3. How did I get the 15? 5 multiplied by 3 is a 15. So my task now is to extract as many bundles of 7 that I can from the 15. So clearly we have two bundles of 7s, right? 7 plus 7 is 14. So there are two bundles of 7s. So this is like saying, all right, we can rewrite 15 as 14 plus 1, right? So 14 represents two bundles of 7s plus 1. So I'm going to write the 1 below over here, all right? So this is my 1, and then 2 times 7. So 2 is, we extracted two multiples of 7s, right? So I'm going to put the 2 here. So 5 times 20 is, 5 times 4, I'm sorry. 5 times 4 is 20. 20 plus 2 is 22, right? So 22, let's see how many we can extract from there. 22 is 21 plus 1. So 21 represents 3 bundles of 7. So that means we can rewrite the 1 and then this 3, all right? This 3, not the 7, but the 3. Now we will perform our multiplication by 2. So times, again, this spot has to remain blank. So I usually just put a cross there. And then 3 times 2, 3 times 2 is a 6, right? There are no bundles of 7 possible to extract. So we just have to write the 6. And then 4 times 2 is an 8, correct? 4 times 2 is an 8. So 8 has one bundle of 7, right? 7 plus 1. So I'm going to write the 1 and then that bundle of 7 to its left, and now I'm going to add them up. So 1, this is 6 plus 1, 7, right? But remember, we are adding in base 7. And what are the numerals in base 7? From 0 to 6, correct? So if it goes over 6, then we have to make this a 0. So we have 6 plus 1 is 7. So 7 is we don't have a numeral to represent 7 in base 7. So we have to just extract the 7 and put a 0. This is like 7, or rather 1 bundle of 7, right? 1 bundle of 7 plus 0. So I'm going to write the 0 here and put the 1 here. All right, so 3 plus 1, 4. I'm actually adding this, not 13. Let me make that clear. All right, so we have the 1 up top here. So 3 plus 1, 4 plus 1, 5, which is less than 7, so which is less than 6. So we are fine. And then this 1 here. So it's 1501 base 7 should be our answer. All right, so let's go over the solutions here. So the solution says, first we multiply 5 times 315. They also extracted 2 bundles of 7, right? 2 bundles of 7, and 1 was remaining. So what do they do next? Record the 1, carry the 2, and that's exactly what we did here. We recorded the 1 and we carried the 2. What next? It's, well, they're trying to multiply. They've carried the 2. So they do the subsequent steps in the next slide. All right, but remember the value, the final result we got, it was 1501. So let's go to the next slide and see. Well, over here they have the 1, and then let's see, over here they continue with the solution. Let me pull this up. So next they multiply 5 times 4 plus 2. So 5 times 4 is a 20. All right, so 20 plus 2, 22 base 2. They extracted 3 times 7 and 1, so 31 base 7, and then record the 31, and then finally it was 1501. Let's see, 116, 1501 base 7 is the same that we got. They showed it in so many steps. All right, we did it very quickly, all right, in a short amount of space, right? We are now going to learn about dividing in different bases. However, I'm going to begin by going over the process of dividing decimal values, because we are going to use the same process to divide in other bases, except that when we divide in other bases, we just have to remember that the numbers are in a different base. So we have to follow the multiplication and subtraction process for that base and not decimal. But the overall process of dividing is going to be the same as that of dividing decimal values. All right, so I'm going to, for now, imagine that this was a decimal division, and I'm going to work this out here. So the number given is 3410 divided by 5. So if we were doing this division in decimals, the first thing that we have to think is, what should we multiply the 5 with to get a value of 34? All right, 3 is less than 5, so we have to work with 34, the two left digits here, 3 and 4. So 34, and then we have to think of, in terms of multiplication, what should I multiply 5 with to get a value which will be close to 34 without going over, right? So 5 times 6. So here we have to recall our multiplication tables. So 5 times 6 is 30, which is the closest we can get to 34 without going over. So we write the 6 as a value of the quotient, and 6 times 5. 6 times 5 is 30. So we write that 30 below the 34, and the next step is to do a subtraction. So 34 minus 30 is a 4, and then we bring down the 1 and it becomes a 41, and we start the process again. We have to think, what should we multiply 5 with to get a value of 41, or to get a value closest to 41 without going over. So 5 times 8 is 40. So we write the 8 on top as part of the quotient. We write the 40, the product of 8 and 5, 40. Below the 41, we do the subtraction. 41 minus 40 is 1. And now we bring down the remaining last digit, which is a 0, and we repeat the process. What should we multiply 5 with to get a 10? So 5 times 2 is 10. So we write the 10, the 2 on top. So 10 minus 10 is a 0, and our final answer would be 682, which is the quotient, and the remainder is a 0, right? So this is how we would work a decimal division. We use the same process when we divide in a different base. However, we have to remember that when we were doing the multiplication, that is what should we multiply 5 with to get something close to 34 and all that, we have to do that multiplication in whatever base we are working with. Likewise, when we are doing the subtraction, we have to remember that the subtraction has to be done in the base that we are working with, in the base that the numbers are in. All right, so I'm going to erase this and work this division step by step using the same process, but again keeping in mind that we have to multiply and subtract during this process in base 6. All right, so let me just erase this and start fresh. All right, so the number given to us is 3410 base 6 divided by 5 base 6. All right. So we have to think here, what should we multiply 5 base 6 with to get a value closest to 34? But this 34 is in base 6. All right. So what should we multiply 5 base 6 with to get a value closest to 34 without going over? So I'm going to start with the multiplication in base 6 for 5. So, and I'm going to write some of these multiplication values. So 5 base 6 times 1 base 6 is 5 base 6, correct? Then we have 5 base 6 times 2 base 6 would be how much? It's 5 times 2 in decimals is a 10, correct? It's a 10, but this is base 6, so remember how we learned the multiplication. You can multiply initially as a decimal, but to convert it to base 6, you have to extract bundles of 6, all right, and also represent it as one bundle of 6 plus a certain value, the remainder, or 2 bundles of 6 or 3 bundles of 6, as many bundles of 6 you can extract from the decimal value, and then you will write it in base, whatever base you're working with. So how many bundles of 6 can we extract from 10? Just one bundle, right? So if you extract one bundle of 6 from the 10, what will you be left with? 4, right? 4 units. So the way we write the answer is 4, the units in the rightmost place position, and this bundle 1, all right, this bundle of 1 goes to the left. All right, so 5 base 6 times 2 base 6 is not 10, it is 14 base 6. All right, then let's do another one, which is 5 base 6 times 3 base 6. So again, multiply it as if it's a decimal, but then we have to convert it back to base 6. So 5 threes are 15. And how many bundles of 6 can be extracted from the 15? 2 times, right? 2 times 6. So 2 bundles of 6. And what is remaining? 3, correct? So 2 times 6 is 12 plus 3 gives us a 15. So this is a 3. And so 5 base 6 times 3 base 6 is 3 on the extreme right digit, and then a 2 because 2 bundles of 6 was extracted, correct? So we have 23 base 6 for the answer. And let's do one more time, one more multiplication. 5 base 6 times 4 base 6 is how much? So 5 times 4 in decimals is 20. So how many bundles of 6 can we extract from 20? 3 bundles, right? 3 times 6 is 18. So 3 bundles of 6 plus how much remains? 2, right? So the units is 2, and then 3 bundles, that 3 goes here to the left. So we have 32 base 6. So what we see over here is 32 base 6. This 32 base 6 is closest to 34. All right, so we are going to write this 4 in the quotient. This is going to be a 4 here. And this 32, the product of 5 base 6 and 4 base 6 goes below the 34. So I'm going to write that as 32, and then we do the subtraction process, same as what we did when we were dividing in decimals. So now 4 minus 2. Now again, this subtraction has to be in base 2. So you have to recall the rules of subtraction in different bases. So 4 minus 2 is 2. All right, if the number above is greater than the number below, it's easy, simple. All right, you just do 4 minus 2 as if it were a plain simple decimal division, although it isn't. But if the number above is greater than the number below, it's just 4 minus 2, which is a 2. So in the next step, we are going to bring down the 1. All right, 21. So we start the process all over again. What should we multiply 5 base 6 with to get a value of 21? So let's look at the multiplications that we already worked here. 23 is greater than 21, so we cannot use that. 5 base 6 times 2 base 6 is 14, so we have to go with this value. 14 base 6 is the closest to 21. So I'm going to write 2 on top and the 14 below. All right, and then do the subtraction. Now this time, as you see, 1 is less than 4, so we have to do some borrowing here. All right, so we are going to borrow a bundle of 6, from the 2, one bundle of 6. And when that happens, this 2 is going to lose one bundle, and it's going to become a 1, and we are going to write a 6 over here, and then on the right side. So the way we do the subtraction is 6 plus 1 is 7. 7 minus 4 is a 3. So we are going to write a 3 here. And 1 minus 1 is a 0. So we are good there. All right, so this is 6 plus 1 minus 4 is what we do. Now we have to bring down the 0. So let's bring this down here, this 0, and write it next to the 3. All right, and we repeat the process. What should we multiply 5 with to get a value closest to 30? So it seems 32 is greater than 30. We cannot go with this. We have to go with 5 times 3. 5 base 6 times 3 base 6, 23 base 6. So I'm going to write this 3 up here. So 3. And then write the 23 base 6 below. All right, and we have to again perform the same process of subtraction but in base 6. So 0 is less than 3, so we have to borrow a bundle from the 3, a bundle of 6. So this becomes a bundle of 2 when we extract one bundle from the 3, and we have a 6 here, right? One bundle of 6. So 6 minus 3 is a 3, and 2 minus 2 is a 0, so it's 0, 3. All right, so our final answer will be 423, remainder 3. All right, that's our answer from dividing 3410 base 6 by 5 base 6. All right, so what I'm going to do is I'm going to erase this and pull up the solutions to see if they got the same answers or not. So let me pull up the eraser first and erase it, and then oops, I removed the, all right, that's fine. I'm going to write up here 43 remainder 3. All right, but let me erase this also, because otherwise this will clobber on the solution that will just come up. Okay, so let's pull up the solutions. The multiples of 5 in base 6. So just like us, they also did the multiplications here. So 5 multiplied by 1 is 5 base 6. 5 base 6 times 2 base 6 is 14 base 6 is what we had gotten to. 5 base 6 times 3 base 6 was 23 base 6, and 5 base 6 times 4 base 6 is 32 base 6. Let's see what else they have here. Oh, they did multiplied by 5 base 6 again, and they came up with 41 base 6. And they did the division right here. So 5 base 6, how many times 5 base 6 goes into 34? We saw it was 5, where it is, where it's here. 5 base 6 times 4 base 6 is 32 base 6. So they put the 4 here and the 32 below, and then they did the subtraction. So 34 minus 32, remember, was straightforward because 4 is greater than 2. So they wrote the 2 here and brought down the 1. And next they again repeat the process. What should we multiply 5 base 6 by to get a value closest to 21 without going over, and 14 base 6 was the one to choose. So we write the 2 up here and the 14 down below. So 21 minus 14 in base 6 is 30, was same, for 21 minus 14 base 6 is 3, but we bring down the 0 to make this a 30 base 6, and we repeat the process to find the value which is closest to 30 without going over, and that's 23 here, right? 5 base 6 times 3 base 6. They write the 3 here, the 23 below, and they do the subtraction for a value of 3 base 6 as the remainder. All right, so that's the same as what they worked, the way we worked, right? So the quotient is 423 base 6 and the remainder is 3 base 6. So that's how you have to write eventually the final answer with the base shown as the subscript. Okay. So here we go over, well, it's actually a reminder of the process of subtracting. And that's what they do, which we already did when we were working through the division process in the previous slide. So what they say here is, be careful when subtracting, when we had to borrow when subtracting 2 different times. In each case, since we are working in base 6, we must borrow a group of 6 from the preceding column, right? So therefore, we were adding 6 to the number on top, and then we were performing the subtraction. So that's what they are trying to remind us here. And then we can always do a cross check to make sure the division, the quotient multiplied by the divisor plus the remainder gives us the dividend. 3410 was what we had divided. So when you take your quotient that you found from the division, multiply it by the divisor, which was a 5 base 6, and then add the remainder to it, you should always end up with your dividend, which is 3410, whatever you divided base 6. All right, so you can do a cross check and that will tell you if your division was right or not. So now we conclude the fourth section in chapter 4, which was on computation in different bases. Okay.